Okay, so we are doing, oh, actually, there's a few more of these I need to erase. We did number 1.
It was on Mary's desk.
It was on Mary's desk?
Yeah.
That's tough. All right, we gotta do a little bit of moving today. You guys ready to go? Okay. P7, we started last class. P7, we started last class with some inequalities. You guys seem to remember how to do this, right? We set it up exactly as we see it. And then we had to do the inequality where we flip the inequality and make the opposite side negative. So we did 2 examples of those, pretty basic. We're going to do the same thing for C and D. Are you guys ready? If you feel good, start without me, okay? On this first one, I've got to set it up exactly as I see it. So I'm going to do 2x minus 1 is less than 1. And I also have to do 2x minus 1 is greater than negative 1. We just have a little bit more simplifying here to do. It's not just add or subtract a number to the other side. This time it's add 1 and then divide by 2. I may get some fractions here. I'm not going to stress. I also may not get some fractions here, and that's going to be okay as well. 2x is less than or equal to 2. Divide by 2. I get x is less than or equal to 1. X is also greater than or equal to 0. Are those 2 inequalities going towards each other or away? I don't think away this time.
Each other.
Towards, right? Bigger than 0, but less than 1. They got to meet in the middle. So I'm going to draw my number line here. We're going to close circle since it's or equal to, and we're going to go towards each other. Someone last class was worried about if I was going to ask it like this on a quiz or a test. If I want you to graph it, I'll put a graphing line on there. Okay, so I'll say solve and graph. I just want you to start understanding what do these numbers mean? What do those inequalities mean? We could even write this in interval notation as 0 to 1, correct?
Yeah.
Good. So we can write this interval notation, inequality notation, and we can graph it on a number line, okay? We're going to do the same idea for the next one. This one is going to be a little bit opposite because it's a greater than, so we'll do 3x plus 6 is greater than 1, just like it's written. And then we'll go 3x plus 6 is less than negative 1. And then again, start simplifying, start combining like terms, get x by itself. This is the one where I do kind of get weird decimals, weird fractions, and I'm going to let that be. It's going to be okay. This time I want numbers that are greater than negative 5/3 and smaller than negative 7/3. This time they're going to go away or towards away. And sometimes that might be a little bit of remembering where my fractions, which ones, when they're negative, which one's bigger, which one's smaller. But negative 7/3 is smaller than negative 5/3. Sorry, that's about as neat as it's going to get today. And we're going to go open circle away, open circle away. That was a nice little review. We knew that from before, right? Okay, perfect. The next part of our notes is now doing interval notation, but it's not just a little linear equation like this. It's going to be a quadratic or a polynomial of some kind, okay? I think the easiest way is to start by looking at it on the calculator, okay? So we're going to skip number 2 for right this second. We're going to come back to it. We're going to jump down to number 3. We're going to graph these in the calculator and sketch a graph and see what interval they want from us, okay? So we'll start with that first one. We're going to graph in y1, and we're going to get a picture from it. From there, we're going to decide where is the graph less than 0 and write the interval that's true for that, okay? So let's pause, let's graph it first, okay? Just have to have my equations out with me, okay? Going to my graphing calculator, I'm going to go 4x squared minus 12x plus 7 We only have one equation. Your Zoom can just be your normal standard window. So if it's on something funny, go press Zoom 6 so we can get our standard window. And do I want to do zeros or do I want to do intersects here?
Zeros.
Zeros, why? Because we're solving. Solve is the word for zeros. Also, I only have one graph. I need two different graphs in order to do an intersection. I only see a blue graph, so I'm just going to do zeros. So let's find those zeros. Left bound, right bound. One zero is at 0.8, and my other zero is at 2.2. So I've got my little quadratic over here. I've got a zero at 0.8, and I have a zero at 2.2. Okay. Now I want to know where if the graph is less than zero. Where is my graph less than zero? Negative what?
Negative 0.8.
Ooh, nope.
No way.
That's the notation we're about to use. Michael? It's between my two zeros, right? Basically, where my graph is less than zero is when I'm below the x-axis. So when I'm below the x-axis, that means I'm less than zero, less than or equal to zero. And then when I'm above the x-axis, that's when I'm greater than zero. So I want to know, remember this is the same thing as y1. Where is my y less than zero? My y's are less than zero all down here. And so Michael, you gave it to me in inequality notation. Let's do interval notation. In this case, since we're just going from 0.8 to 2.2, we're just going to list those two together. And then am I going to parentheses or bracket them? Parentheses. Because it's just a less than, not an or equal to. Okay. Let's do number C since I can still see all my work for letter A and then do letter C at the same time. So same thing, go graph that on your graphing calculator. And then we'll sketch a graph over here. Last period, they were really worried about, do I have to graph? You don't have to do anything. I'm just trying to give you all the tools that you might need. So I personally find it helpful to graph because it helps me know what interval to do. If you don't need it, don't do it. It's okay. Now, if I ask for a sketch of a graph, then you need to be able to give me one. But if I don't ask, you don't have to. I am still good with my normal window. I'll come over and graph. Whoa. Is that what you guys got?
Yeah.
I got something different this morning and nobody told me that they got something different.
I got it. That's not it.
Did I do a plus this morning? Sorry, let me just try something. Right?
Oh, it's to the third, not to the square.
You just do it to the square?
I did to the square. And that's not a term, but
Maybe I'm thinking of something different. I did one this morning that did not look like that, but I guess maybe this one does. So I have 3 zeros that I need to find.
Wait for the union.
We're gonna do some unions in here. Well, alpha period, if you're watching, I'm so sorry. I don't know what we did wrong this morning, but this was not the graph we looked at this morning. All right, I gotta keep it moving. I'm so sorry. So now I am still gonna sketch this and let's find all of our zeros, okay? I'm gonna find second trace zero, all my zeros, and then I'm gonna graph it. Do a little sketch of my graph. So I've got negative 2.1. I don't know if those are at the right spot, but that's okay. And then 0.1. And then 0.19, or if you rounded that up to 2, I'd be okay with that. 1.9. Okay. Now, guys, you said we needed to we needed to do unions. This is not good class. Guys, thanks for sticking with me. We need to do unions today because we got several different intervals, right? This says less than 0. Where am I going again? Above the x-axis or below? Below the x-axis. So I got this interval right here. I got this interval right here. Who can tell me what that first interval is going to be? Parentheses or brackets? Parentheses, very good. That one was pretty easy. I'm just going from 1 0 to another 0. Then I'm going to go 1.9 until what? Positive infinity. Anyone know why it's positive infinity? Because it looks like it's going down forever. It looks like it's going to negative infinity.
It's more than 1.
Because it's the x's, and the x's are anything bigger than 1.9 is going to keep us below the x-axis. Very good. That can be a hard thing to understand. So if that's still a little puzzling to you, don't worry. We've got like 10 more problems like this today. So we're going to keep working through it, okay? But it's my x's. So I'm going from this x to that x. I'm going from this x and then forever to the right, which is just bigger and bigger x values. Okay? Let's do the exact same thing for the next two. One thing I am going to do before I plug this one in the calculator, I am going to move the 1 to the other side so I can just keep doing my zeros. I'm going to move that to the other side and do my zeros.
Can you do that all the time?
Do what? Move it over to the other side? If I'm graphing and I'm solving, yeah. I always hesitate to say, yes, you can always do anything because there's generally an exception in math, but I think that one is a pretty fair always to do. Okay, let's see. X squared minus 4x minus 1. I'll be quiet. You find your zeros. You label your little sketch and do your interval notation. Once you think you've graphed it, find your zeros, write your inequality. This time though, we're greater than 0, so think about what that means. I've got 2 intervals I see here that are greater than 0. How am I going to write the Avery?
I did negative infinity to negative 0.2.
Perfect.
4.22.
Perfect. And did you use parentheses on all of them? Perfect. Good. That was an excellent, Abe. Good job. When I'm going all the way to the left-hand side, it's keeping it up above the x-axis. It's negative infinity. Anything from negative infinity to negative 0.2, I can plug in for my x and get a positive number. Also, anything between 4.2 and positive infinity, I can plug in and get a positive number. When you're done with that one, do that last one for me. We're going to do it by hand in a second. But I am going to argue these were not easy to do by hand. They weren't factorable. They would either need, like, they have some kind of complex answer, so it's easier to just plug them into the calculator. You won't have to do both, but I'm going to show you when we do the ones by hand that I'm going to sketch a graph still to help me. If you don't need a graph, you don't have to use one, but I think it's going to be helpful. This one's kind of a special case. I want all the numbers that are greater than or equal to 0. Is there anything that's just less than 0 here? Is there anything that's below the x-axis? Everything is a 0 or above. So how do I say that I want all numbers? You could do negative infinity to positive infinity. However, you can also do the fancy R. Did you guys use fancy R's in algebra 2? Okay. That means all real numbers. So all real numbers would work here.
You just write it out.
I mean, you can write all real numbers, but how much longer does it take to write all real numbers than to do this? And that's why half of our like little shortcuts exist, is just because it's a little easier or faster to write.
Reals.
All reals. Okay, go backwards to number 2. We're going to do basically the exact same thing, but this time we can factor, we can solve, we can do it a little bit cleaner by hand, but I am still going to sketch my graph. If you decide you don't want to sketch a graph, that's on you, but I'm going to tell you that we're going to have intervals like this every single time, and so in order to know what the correct interval is, I think it's very helpful to graph, okay? Let's go back up to number 2A then, okay? This one says solve. We have not done a lot of factoring, but I'm going to see if you guys remember how to factor from algebra 2. X squared plus 7x plus 12. What numbers multiply to be 12 and add to be 7?
4 and 3.
4 and 3. Very good. They're both going to be positive. And so when I solve and I get the zeros, what are my zeros?
-4, -3.
Good. -4, -3. I'm going to ignore that inequality right now because these are actually my zeros. This is what x equals. Those are my equal zeros. Now I'm going to graph it, and then that's going to help me find my inequality where x is between two things. -4, -3. You guys know how I know it's an upward shaped view? An upward parabola? Why? What about this where it's what? Positive. Very good. So positive means upward facing, negative would be downward facing. So this is what my graph would look like. And I want to know the interval here that's less than 0. So where am I less than 0? -4 to -3. And that is my interval notation. -4, -3. Can I include -4 and -3? No parentheses. It's not too bad, is it? All right, let's keep doing a few more examples. This is more factoring practice than really anything, but we're including some interval notation practice while we do it. So we'll go to the next one, factor that. Ooh, that's a difference of squares. You guys remember difference of squares? X what? X what?
X squared. Okay. No, you gotta do it. You gotta do it.
X plus 4, X minus 4. That's as good as it gets. I can't simplify anymore, so I just say my zeros are -4 and +4. Say one more time. Great question. I don't have another square in there. So if you had x to the 4th, then yes, it would be x squared plus 4 and x squared minus 4, and then you would break that one down more. Great point, and keep looking for that. Okay, so I'm going to go have zeros at -4 and at +4. And this is another parabola upward facing because it's positive. And my sketch looks a little funny, but it doesn't have to look perfect. It just kind of gives me a guideline. This time, though, I want greater than or equal to 0. Avery, you got it?
Parentheses, -infinity, comma, -4. Then like the bracket,
Good.
and then you, and bracket 4 to plus.
Perfect. Avery knew that we were going above the x-axis. And again, when the arrows are there, it's -infinity is where we start. We're ending at positive infinity, and we're hitting 4 and -4 in the middle. Reminder, you never use brackets for infinities. I think you guys are pretty good with that, but I just want to remind you. All right, once you got that, go ahead and flip your paper over. Got a few more like this. Want me to keep talking about them out loud, or you want to kind of do them on your own? Keep talking, I can keep talking. If you don't want to listen to me, just ignore me and just keep doing them on your own. Just check in every so often. So I'm gonna factor my X out. Now, Francie, this is what you were talking about a minute ago, right? Now we can keep it going. I love that you kind of were one step ahead of me. That makes my zeros here what? Good, 0 and positive and -2. Remember that X out by itself?
Oh, I was just gonna ask, what were the ones where you had like, square multiplied square or something like that? It's like factoring, I don't know what they were called. You know what I'm talking about? It's like,
I really don't.
it was a form of factoring, I don't remember what it was.
Was it like a quadratic?
Like,
Was it like I kind of showed a minute ago, x to the fourth, like -16? And then you factor down and then it's a square?
well, it was like,
Or are you talking about difference of cubes, like SOAP stuff?
I think that's what it was.
Yeah, I'm not really gonna talk about SOAP stuff today, but that is like a tool in your toolbox that technically I could ask you to use. Does that answer your question?
Yeah.
Okay. Okay. Remember the zero of 0, that's kind of a little bit of a funny thing, comes from the fact that I've just got an X by itself out there. I meant to go this. That X by itself out there means 0. Okay. So let me graph at 0 and at +2 and at -2. Now this is a little confusing because we're going to talk more about this in like a few units, but this is going to be a polynomial graph that just kind of like snakes around. Do you remember, is this one going to end high or is it going to end low? It's going to end high. Why do I know that? It's going to just cross through all of the zeros. Very good. It also started as a positive number. So when it's positive, it's going to end high. And then another thing, I don't know if you learned this and need to remember it, or if you never learned this, the exponent tells me if it's going to go both up or if it's going to go opposite directions. And so since it's an odd number, it's going to go in opposite directions. O is in odd and opposite. So if it ends high, it's going to have started low. So start low, and then it's going to cross, 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 and it's going to end going high.
I think it was even.
This test that you're doing on Thursday is a full graphing calculator test. So if you don't remember, could you graph that in the calculator? 100%.
Do you go through them if you're even and they bounce off them if you're odd or whatever?
Other way around. You cross it if it's a single, like, rose to the first exponent. If it's raised to the second exponent, then you bounce. And if you raise it to a cube exponent, you kind of make like a cubic function through it. Again, this is a little bit ahead because we're going to spend time on this in chapter 2. We'll spend a whole day like graphing polynomials. So if you forget this, that's okay. But this is what the graph should look like. And then I want to do where we are greater than 0. Who can give me my first interval where we're greater than 0? Joey?
-2.
Yep.
To 0.
Good. Am I brackets or parentheses?
Bracket. No, parentheses.
Parentheses. Good. Why is it parentheses again?
It's greater than.
Just greater than. Good.
Then 2 to infinity.
Very good. 2 to infinity. And then parentheses on both of those. Very good. All right. Let's do another example, another one of these polynomial graphs. Just a hint, it's almost going to look identical. It's just going to have different zeros. Because when I factor this out, I did my GCF first, and then I'll do my factoring. That didn't sound good, did it? X minus 6, X plus 5. So what are my zeros here?
6, -5, 0.
And 0. Very good. Don't forget 0. And then I'll go graph those. Put it over here. Again, this almost looks the exact same as my other graph. It's just got slightly different zeros, it's still a positive and even, or sorry, positive and odd, so it's gonna just start low and high, cross, cross, cross at everything. This time though, I want my graph where we're less than or equal to 0. Who can give me my interval where I'm less than or equal to 0? Avery?
Like the whole, like the answer?
Uh-huh.
Oh, negative infinity,
Uh-huh.
0 bracket, u bracket.
Oh, I don't think 0 first. What? What do you hit first?
Oh, -5.
Hit -5 first. Very
And
good.
then bracket.
Good.
And, bracket 0, 6.
Very good. And that is one reason I do my picture, because unless I write my zeros in order, I don't really know which one comes first. So that's why I draw my picture, so I know I'm making sure that I hit everything in the right order. Okay, the last two are very similar, but they're a little bit of a special case when we get to the end. Okay.
It has an arrow going up.
Great question. Like on this one, the arrow going up here is only when we are positive. It's when we are greater than 0, and our problem wanted less than or equal to 0. So I almost am ignoring the top half of the graph, and I'm only looking at this bottom half right here. Good question. All right, let's move on to the next one. Same idea here, factor, sketch. We want where we are less than or equal to 0. I have one number that is. Why does 4 work?
Because it hits the line.
Because it hits the line. Very good. Now, if it just said is less than 0 and didn't have that or equal to, then you would say no solution or a 0 with the x. But it does want or equals to, and so that means I do need to include 4. I don't know if you used this notation last year in Algebra 2, but we use these kind of fancy brackets to just represent one number.
Why could you put 4 and then like comma 0?
Because 4, 0 is an ordered pair. It's not an interval notation. And if you use an ordered pair when I'm asking for interval notation, I think that you did your interval notation wrong. Because to me, that says I'm going from 4 to 0, which would be like this part right here. And I would say that's not true. And I would also say like the small number needs to go first. Okay. So think about what we're doing. An ordered pair looks a little too close to interval notation. We can't use that. Joey.
Is 0, is that the asymptote?
0, like this line right here, I wouldn't call it an asymptote because we're not approaching it but never crossing it. It's just like the bottom, it's like a bound of my graph. It's like a boundary where you're like, I will not go below that. All right, last one, same thing. Make sure you move that 6x over before you do anything crazy. This is very similar, except I'm asking for greater than 0 here. What's greater than 0?
Is it negative infinity 3?
So negative infinity to 3. I like that. And then what to what?
3 is positive thing.
Good.
It doesn't have to be.
It's basically just anything that's not equal to 3. If it had an or equal to sign, then we do our all reals all over again, but it doesn't have that. So instead, we want everything except for 3. So I want everything over here. I want everything over here. when we start graphing our rational functions and we have asymptotes and we have holes in our graph, we're going to use this notation a little bit more often. So we'll get comfortable with that, where it's like there's no gap, but the gap is the actual number of 3. Okay. All right. I have 3 or 4 more problems left, and they're all word problems. Number 4 and 5 are basically the same word problem. I promise you're going to have one like that on your test. Number 6, and then I know number 7 doesn't have a lot going with it, but it's basically the repeat of number 6, but new numbers. I promise you there'll be one like that on your test. Okay, so let's go through those. You do need a graphing calculator for these. I do think 6 and 7 are brand new. 4 and 5 might be a little review. I think you do word problems like this in algebra 2, but I'm going to treat it like you've never seen it before, okay? Everybody got a graphing calculator that's going to need one? Okay, perfect. It says a projectile is launched straight up from ground level with initial velocity of 256 feet per second. A projectile is like we're throwing a rock in the air. We're launching a rocket. We're throwing a ball. I'm throwing something. That's what a projectile means, okay? The general equation for this goes f of t, so function in terms of time, equals negative 16t squared plus v sub 0 times t plus s sub 0. Okay, that's your general equation. That looks insane, but I promise it breaks down to be something a little bit easier, okay? That negative 16 times t squared is always how you're going to start. If it's not how you're going to start, I have to give you an equation. But if you have to come up with this on your own, so this problem and the next problem, they all start with negative 16t squared.
But we gotta remember that.
I mean, you gotta know it for right now. We're using it right now. V sub 0 means velocity. So that means I'm just gonna plug in that 256 as my coefficient for t. So in this particular problem, I'm gonna start with that negative 16t squared, and then my V sub 0 is my initial velocity. S sub 0 is like where you're starting, like off the ground, okay? So this says we're starting at ground level. Where would that be? At how many feet off the ground? 0. So I could write plus 0, but that just adds some more things that I don't want, so you can leave it just like that. The best math way would be to write f of t. If you don't like function notation, I don't care, write a y. Know that that's what my function is equal to, okay? Everybody okay with how I'm formulating this problem so far? Okay, we need to graph that. And then if you read the rest of these prompts, it says, when will the projectile's height above ground be 768 feet? When will it be at least 768 feet? When will it be less than or equal to 768 feet? All I care about is this graph right here and 768 feet, because that's in every single one of those pictures. So let's go graph those two things, the equation and then that one line, and then we'll see a little bit of a sketch of what that means, okay? And I will sketch it off to the side as we do it. Just type the equation and 768 in, and then we'll talk about what we think our window should be. Okay. Now, my x-axis, my x's are all in terms of time, in terms of seconds, right? When I go over to my window, can I have negative 10 seconds before I threw this ball? No, we're going to start at 0 seconds because we're not psychos, right? Now, when I talk about time too, when we throw this, it's going to go up in the air, and then what's going to happen? It's going to come back down, right? It's going to hit a high point, and then it's going to come back down because we have gravity, right? Now, unless I throw something up like hundreds and thousands of feet high, it's probably just going to take seconds to come back down, right? So I think 10 is probably a good guess. I may go as far as 15, just so I feel pretty good about my graph. But in terms of seconds, it should be pretty small. I wouldn't go 100 or 50,000 seconds. That's a lot of seconds, right? So just 15 seconds is a good place to start. If I need to expand it, I will, but let's start at 15. Same thing for my y. We can start at the ground, it's gonna go up and then it's gonna come back and hit the ground. So I have no need for negative feet. It can't go below the ground, right? We're not dealing with like a bomb or like something's gonna bury itself in the ground. It's gonna hit the ground. In terms of y max, what does it need to be bigger than? 768, that number that you put in. I might go 1,000. You could go 800, you could go 900. Anything there will make sure that you see your line. I'm going to go a little bit higher just so I can really ensure that I see it, okay? Okay. Maybe not the most perfect window, but good enough. I am going to make my X max go a little bit bigger so I can ensure that I see that bottom. We'll go 20. There we go. Okay. So the sketch of my graph looks something like that. Don't look like a parabola. And then here's my 768 feet. We just spent so much time worrying about interval notation because that's what we're about to do here. Okay, first question says, when will it be 768 feet? How'd you get that, Avery? Good, we're gonna do the intersection. We're gonna find our intersection because we wanna see where these two lines meet. So the two places where the line meets, that's when it's exactly gonna be 768. So go ahead and find those intersections if you haven't done it. So 4 and, oh. I am gonna want 0 though, so I'm gonna finish solving for 0, but ABC mouse. I'm not sure why I'm getting that ad because I don't really have a need for it, but okay. 4, 16. Maybe another teacher. My notability is not loving the switch back and forth. Can someone tell me what the other point of intersection is? 12. If you are having trouble finding 4 and 12, I think that that's a very easy problem to fix, but you may need to come see me outside of class for that, okay? So we are exactly equal to 768 feet when we are at 4 seconds and at 12 seconds, okay? When will we be at least 768 feet? Is that going to be above the line of intersection or below the line of intersection? Above, right? Now, when I say it's at least, I like to even put this in terms of something that we're used to, right? What happens if I want at least an 80% on this test on Thursday? Am I okay with an 80? Yeah, at least. I want at least an 80. I'll take an 80. I'll take an 81. I'll take a 90 something, right? Will I take a 77? No. So I want equal to or above. So that means when I write this in interval notation, I'm going between 4 and 12. Do I want brackets or parentheses? Brackets, because I'm okay with getting it exactly at 768 feet. Now, when will it be less than or equal to? Okay. I see two intervals here. From what to what?
Negative.
Good, but we don't do negative infinity in terms of time. 0. And we can do brackets then because it's or equal to. And then from 12 to, and this time I found the 0 just because I accidentally stumbled upon it. But you will need to know what the 0 is because that's going to tell you from the other point of intersection to the 0.
How'd you get just the 0?
Yep, so go second trace 0 and just go left bound, right bound of the 0. Okay. Once you think you got that, on the next side of your page is a very, very similar question. Let's write my equation for that before I let you try to graph it on your own. I've got my equation at the very, very top of the page. This one says the projectile launched straight up from ground level with initial velocity of 272 feet per second. Okay, what's my equation going to start with? How do all of them start? Negative 16 t squared. And then what?
Velocity.
my velocity,
S.
and then my S, but am I starting at ground level again? So I don't need an S.
That much, do you think a lot of them will be?
A lot of them will. I might say like it's starting from 6 feet above ground. It should be very easy to tell what that extra one is. Okay. So let's go ahead. This is the exact same type of problem, but now it's a new equation and it's asking about 960. So can you plug those in? Can you find your interval? Can you figure out or find your window and then figure out what all those intervals are? Okay, take a second and do that.
And do you always put an X on the velocity
Yes.
and if you're
This-
trying from 6 feet, you put an X there too?
Even if there was something, then you would just put 6 attached to the edge,
It's
just a constant.
Okay.
Mhm, good question. And this is like how tall or how high off the ground you are. If I'm launching it from the ground, though, I'm at 0, so I don't need to add anything onto the end. I think that's a pretty decent window up there. What's the unit thing?
Oh, yeah.
You don't have a graphing calculator today?
Oh, no, I have no.
Okay. You just watching?
Yeah.
Okay. You're good, I'm good. All right, when will my graph be exactly 960 feet? 5 and 12, very good. When will it be more than 960 feet? Between 5 and 12, am I gonna parentheses or bracket that? Parentheses. Because if I say I want more than an 80%, I don't want an 80, I want an 81 or more.
Didn't you bracket a lot?
We did because it said at least, and at least to me means that you can use that. And then less than or equal to, very similar to last time, what's that interval gonna be?
0 to 5.
Uh-huh.
Bracket. And 12 says.
Very good. Okay. I got one more type of problem to show you guys. Anybody questions on these projectiles before I move on? Okay. Just gonna do a little show and tell. Okay. This problem says an open box is formed by cutting squares from the corners of a regular piece of cardboard that is 12 inches by 15 inches and then folding the flaps, okay? So I'm starting with a piece of paper, rectangle, a box, whatever you want to call it. Well, I know I don't want an actual square, I want more of a rectangle. Come on. This is 12 by 15. Okay. I'm gonna cut a square corner off in every corner. I'm gonna do that all the way around, okay? Now, I am a human, these aren't gonna be perfect. This is just for demonstration purposes, okay? And what I'm gonna also draw in my picture is the act of me cutting these out. Okay, so now I cut all my little corners out and I now get down to here. I'm gonna show that by just kind of drawing little corners I cut off, and I cut off X from every corner, okay? You can do straight lines, they don't have to be dotted lines, it's up to you. But I'm cutting X off of every corner, okay? My question now is how long is this? Okay. It was 12. Let's say I cut off an inch from both sides. How much is left now? 10. Very good. What if I cut off 4 inches from both sides? Now what's left? 4, right? Because I minus 8. Okay. What am I going to use? What expression am I going to use to represent this length? 2x. Very good. 12 minus 2x. Same thing for this side. What's this side now going to be? 15 minus 2x. Very good.
Would it be 12 minus x? What? It was like 8, it would be 16. Or,
I think you are right. I just think you simplify it down to be 2x.
Yeah.
Okay. Now that being said, there's a maximum that I can cut off of each of these parts, right? This whole side is 12. What's the most that I can cut off of both sides evenly? 6. Why, Joey? Good, because if I cut like 7 off of this side, I can't then go and cut 7 off of the other side because I already cut it all off, right? I can cut it exactly halfway down the middle. Okay, that's going to be helpful in a second. Now, I'm essentially folding this box up, so the equation I'm going to write is in terms of volume. Do you remember what volume is of a rectangular prism? Length times width times height. Now, you have length and width on your paper, right? You have 12x minus 2, you have 15x minus 2. We're going to use both of those. When I fold these little flaps up to make this box, how tall are all the sides of the box? How tall is this? X. Very good. It's X. So my volume equation that we're going to use in these problems comes from length times width times height. It's going to be 12 minus 2x times 15 minus 2x times x. We are going to graph that. Okay, before we get to our calculator to graph that, because I might run out of time, my window for this, you guys told me that I couldn't cut more than 6 off. Whatever the smallest side divided by 2, that's going to be my x max. I can't go bigger than that. Now we know that my problem is asking about this 125. So my y max should probably be at least 150, 200, something like that. But that's going to be kind of the windows that I'm going to input in. Okay. It is a polynomial, but based on the window that we do, it's going to just be this quadratic, and it's going to be the exact same type of problem that we just did on the last one. Okay. Let me enter it in the calculator, see if we can show that. Do not like multiply out 12 minus 2x and 15 minus 2x. I mean, you can, but like, why would I?
Right.
That feels like a lot more work than I need. I know. Give me about 2 more seconds. Ooh. Oh, that's because I didn't do that. There we go. See how this looks a lot like what we were just doing? Can we find our intervals from there?
Yep.
Okay. I believe you have a question like this on your homework. I still want you to try it, but we'll probably need to talk about that at the beginning of class because this was a little short, okay? So try your best, but I do want you to hold your homework at the beginning of class. We'll finish going over this. Anyway. Because I took off an x from both sides of the paper. So minus 1x minus another x minus 2x's. Okay. All right. Anybody, anything else? Okay.